So I think first of all, U of T has a great history of research and innovation. And I think that's one of the main things that attracted me in the beginning. I think I knew that if I came here, I'd be able to get to work with some extremely talented students and colleagues. So that was another aspect. I've spent a bit of time abroad in the US and in Europe and in Germany, and I think these experiences also really strengthened a desire as a Canadian to come back to Canada and do my part to try and help maintain Canada's standing as a leader in innovation and research and engineering. And I think U of T engineering is a perfect place to do that. The general area of my research is nanomechanics. So it turns out when we scale materials down, like metals or semiconductors, down to nanometer dimensions, they exhibit dramatically different properties. So things like strength. So strength of a metal turns out to be orders of magnitude higher than a macroscopic metal. And so my research looks at kind of two objectives. One is to figure out these size scales in mechanics, and two, try and adapt them to use them in mechanics and materials engineering applications. So I think there's a few different applications. One of the key ones is a need in Canada and abroad to reduce energy consumption. So nanomaterials and nanostructures provide a very promising route to design advanced materials which can be very energy efficient. So an example would be a material like graphene. So graphene is one of the strongest materials in nature. And so we can think of using that in materials like nanocomposites, which we can build airplanes out of, build cars out of, reduce weight, and ultimately save energy, save fuel. So that's one of the main motivations, I would say. As an educator, I look to try and motivate a next generation of students. One of the goals for me personally will be to motivate those students to look at some of these novel areas of nanotechnology, and so I hope to kind of help push them in that direction. I think for some of these new areas, new novel technologies, there's a need for students to have skill sets which really cross disciplines. So that's something I would look to do as an educator, is design curriculums that address that. As a researcher, I think in my research area, there's been a gap between first understanding these novel properties, but then the gap is really trying to apply them to real-world applications. So that's something I'll look to try and address in the next few years, is to start to bridge this gap. I would say I've kind of always been interested in how things work. I can remember as a kid kind of taking things apart, trying to understand how they work. But probably it was really in high school when I first kind of knew that I wanted to take this path towards engineering. I can recall working on a robotics project where we had engineers come in as volunteers and teach us how to design the robots, build the robots, and that was really the first time that I knew what engineers can do, and so that was really a motivator there.